Hello, everyone. This is Ethan, and long time no see. I will be hosting today's CIOE webinar. And again, I would like to thank you all for attending our event and be so supportive under the circumstances of this pandemic. And then, I would say it's an honor to invite Allen Liu from the Focuslight Technology to deliver this presentation about the coating thin film technology and coating pre-deposited substrate for optoelectronic. This entire presentation is about 30 minutes, and we will be moving on to the Q&A section, which is about around 10 minutes. So please feel free to submit your question down below. So without further ado, please welcome Allen.
Dear audience, hello everyone. This is Allen from Focuslight, and it's been my honor to have this presentation here. And my topic is coating thin film technology and coating pre-deposited substrate for optoelectronics. And let me give you a brief introduction for myself. And I was engaged in Focuslight since 2013, and with more than 9 years of experience in product management and product planning and business development. And now I'm just responsible for the advanced materials product line. And today my topic is coating thin film technology and coating pre-deposited substrate for electronics. And before we start here, and just mention, all of my information is just from public only for this webinar, so please do not use it for other purpose. The 4 parts here, the first part is coating thin film technology, how to choose solder as a bonding interface to get a better device, electron device. And the second part is coating pre-deposited substrate for electronics, how to design and develop a better substrate with coating and the thickness design for every layer. And the third part is called technologies. What is our technology, and what is the application data and for the device, and then a conclusion in the last. So this is a simple structure for a device. You can say the laser chip on the top layer, then we use solder as a bonding interface to connect the laser chip and on the mounting substrate. Then we bonding the module on a heatsink. So there's 3 functions for the bonding interface. The first one, we use the laser, we connect the laser chip on a substrate by a bonding interface. So the first one is a mechanical connection. Then we need to transfer the heat from laser chip to mounting substrate, even to heatsink. So the bonding interface has a function for heat conduction. Then when the laser chip is emitting, so we need to transfer the electric. So we will conduct the electric from the laser chip to the heatsink as a electrode. So how does a bonding interface affect the device? You can say when you have a good bonding interface, the device has a higher performance, higher stability, and higher reliability. If the bonding interface is not so good, the device will be soon, will be failed very soon. You can see the example. And when we use indium solder as a bonding interface, you can see the indium solder will flow out when working on a very long time because of the electromigration. Then there is a gap between chip and the substrate. Then the heat will be higher. Then the device will be filled soon. When we use some solder with thermophysical effect, you can say the bonding interface will have a crack then the device will be shown. Also, when the bonding interface has some void because the bonding interface maybe is not uniform for the solder, so the bonding interface will have some voids. Then the heat will be higher because the L is conductivity of L is not so good, so the heat will be higher, so the device will be filled soon. So just a quick summarize for bonding interface. We need to combine the thermal and the thermal stress. Then we need to consider the bonding interface have a good electric conduction, and then have a good durability in the some working condition. So choose a good bonding interface is very important. Our purpose is how to integrate all the material layers into one by using a solder layer as a bonding interface. So these are some data comparison for some physical properties of different solder materials. You can see some solder have a higher melting point. Some solder has a very lower thermal conductivity. When we choose a solder as a bonding interface, we need to consider this parameters. For example, if the solder has a very low thermal conductivity, the heat will be transferred from laser chip to substrate will be slowly. So we need a higher thermal conductivity to transfer the heat. Then we need some CTE closely to the laser chip to get a very low stress application. And we also need to consider the solder is very good for the environment because for example, for the lead is very dangerous for environment. And for silver solder, you can say the thermal conductivity is higher and the CTE is low enough, but the melting point is too high, more than 900 degrees. So it's very hard to do the laser chip bonding in mass production because the melting point is too high. So we consider that gold-tin is very good for the laser chip bonding as a very reliable bonding interface. Then you can see some solder like tin, silver, copper with a very low thermal conductivity, and the melting point is higher, but you can see the thermal conductivity is too low. So the heat will be transferred slowly from the chip to substrate. So we think gold-tin is a very best solution for laser chip bonding. So this is the comparison for indium solder for gold and indium solder and gold-tin solder because both of two is very common solder in the industry. Before we saw this result, we can see the stress strain profile. You can see the gold-tin is brittle enough, and the indium solder is ductile. So for the indium solder, it's had high ductility and but with thermal fatigue effect and electro migration and thermal electro migration effect. So I think the indium solder is good but not reliable. It's good for the performance but not reliable for the device. And however, for gold-tin, it's much stiffer with a higher durability and higher reliability. And because gold-tin is stiffer, so with some little stress and strain compensation for the device bonding. And to solve this problem, we can use a buffer layer, for example, ceramic or copper tungsten as a buffer layer to reduce the little stress. So this is data samples for the gold-tin's reliability. We use our self-made gold-tin pre-deposited copper tungsten substrate to bundle the laser chip, to connect the laser chip and the heat sink. So the copper tungsten is a buffer layer, and we deposit some gold-tin on the copper tungsten substrate. Then we bundle the laser chip. So we test the device lifetime under the current 80 amps with a CW mode, and we got more than 26,000 hours lifetime, and this device are still under the test. We want to get more than 50,000, then well, maybe higher to 100,000 hours. And the equipment to test the lifetime is our self-made equipment. To test the thermophysical of the gold-tin, thermophysical effect of the gold-tin, we also use our self-made ceramic with gold-tin deposition substrate and bonding the laser chip and the hard post condition, because the hard post condition is a very tough condition for the thermophysical test. And the test condition is Y second on and Y second off. The current is 42 amps. Output power of device is 200 watt. And you can see we get more than 80 million shots, which means that the time would be 10,000 hours, and it's still under the test. And to test the gold-tin under high current condition, and we also use our self-made copper tungsten substrate to bundle the laser chip to make the device called the GR02, and the lifetime current is 300 amps, and the power consumed around 400 amps, and the pulse wise is 500 microsecond, and the frequency is 9 Hz. You can see we get more than 18 million shots without any power drop. So gold-tin is very reliable, and durability is very good, and but for the gold-tin has different forms. You can say gold-tin paste, gold-tin preform, and gold-tin thin film. I want to go through the forms one by one. Just for a conclusion, if you want to use gold-tin as a solder to do the laser chip bonding or other kinds of chip bonding, you need to use gold-tin thin film. Because the chip bonding is very sensitive, so we need the uniformity is higher, and the precision is higher, and the void is lower. So we need to be careful for this kind of application. We just use gold-tin thin film. If you use some not sensitive application, for example, for the AuSn design, not a chip bonding, for the AuSn bonding, you can just use some gold-tin paste or gold-tin preform, because the cost is lower. So just a brief summary, bonding interface is very important for device performance and reliability, and the gold-tin is very reliable in bonding interface layer. So we use gold-tin, and gold-tin thin film is the best solution for laser chip bonding. For the second part, gold-tin pre-deposited substrate for optoelectronics. You can say we actually for substrate we have different layer in the construct. Gold-tin as a solid layer, and the second layer is gold as the electroconductive or oxidation prevention layer, and the nickel as a diffusion barrier layer, copper as a thermoconductive layer, because the thermoconductivity of copper is high enough. Then the aluminum nitride as a structure layer. So we just combine every layer into one to get a very low thermal resistance for the substrate. So thermal resistance is a key point for the substrate. Different layer has a different effect on thermal resistance. You can say we just design and every layer, you can say the thickness of nickel and the thickness of copper and the thickness conductivity of aluminum nitride and the thickness of gold and the thickness of gold tin. You can see interesting things in the for the thickness of copper. If the thickness of copper is from 0 to 0.3 millimeters, the thickness, the thermal resistance will be lower very quick. Then, if you increase the copper thickness from 0.3 to 1 millimeters, you can see the thermal resistance will be higher. So thermal resistance for the copper has a key point. So when we design the substrate, when we design the thickness of copper, we need to find a very comfortable point. For the thermal conductivity of aluminum nitride, you can see when we increase the thermal conductivity of aluminum nitride from 50 to 100, you can see the thermal resistance will be decreased very quick. Then we increase the thermal conductivity from 100 to 150 to 250. Then the thermal resistance will be done very slowly. So we need to find a cost-effective point for thermal conductivity of aluminum nitride. So because the copper has a higher CTE than aluminum nitride, so when we design the thickness of copper, we need to consider the thermal resistance and thermal stress. So the CTE will be close to the laser chip. So we need to use some optimization for the copper for the thickness of copper. So we get a very best solution for the thermal resistance and the thermal stress. So when we say the thermal resistance and the thermal stress is important, so how thermal resistance and the thermal stress affect the device? You can say when the thermal resistance is lower, you can get a higher power and higher efficiency for electro-optics and very low wavelength and a very narrow spectrum. The shape of spectrum is very narrow, and the device failure will be nice. When we get a lower thermal stress, the wavelength will be lower, and the polarization of optic will be higher, and the failure will be less. So if you use a substrate with a higher CTE than laser chip, the string will be compressed string. Then the wavelength will be lower. We call this blue shift. If you use a substrate with a lower CTE than laser chip, then the tensor string will affect the wavelength. We call this red shift because the wavelength will be higher. So these are two kinds of process flow for different substrate. The first one is mainly used for optic combination, and the second one is for high power laser diode. You can see the only difference is a copper process. because for second one, you can see we use dry film and copper plating and grinding and cleaning and etching. You can see all of the process is just for the copper process. We use dry film to get a high precision pattern design, and we plating the copper. So why we use copper for this kind of device? Because in high power laser diode, the power is very high. We need a copper as a high conductivity layer to transfer the heat. So we just use a copper. So what is our core technologies and what is our product data in application, even in the product test data, even in some test data in application? As you know, we have rich experience in application, and we got know-how because we not only make the ceramic, we also make the device. So we got know-how, we got a result to confirm our substrate is good or not. And we have Atiotic bonding and thermal management and thermal stress control and interface materials and thermal engineering. And we can test, analyze the result to guide our design development of substrate. And since in 2014, we published the high power packaging of high power semiconductor lasers in Springer. And we have strong thermal optic stress simulation, even mechanical design capability, and so which will guide our product design and development. And we have more than 10 years of metallization coating experience for different solders, different bonding interface. And we also get more and more data every year to control, to do quality control and production control. We even have high precision dry film machine and technology. You can say our exposure machine, developing machine, dicing machine, and laser marking, the AOI inspection. And we are developing more and more automation equipment in our production to increase the efficiency, to ensure the quality, stability. So for our equipment, every year, every batch, we will build the SPC system to ensure our metallization process. And for every batch, we will monitoring the melting point of coating, because this is the key point for the whole substrate. So we need monitoring the coating, not only the thickness of coating, but also the melting point. And we record the video for every batch. And even for some reliability test of coating, we do adhesion test and wettability test in every batch, every day, every batch, every equipment. And for other metallization, like gold plating metallization, we do the plating cycle test, adhesion test, and even baking test at a high temperature. You can see the condition is high, and the temperature is high to 350 degrees and more than 10 minutes. And then we even do the thermal shock test to ensure the reliability of gold plating. Also do some application test, because usually our customer will use a substrate to do the wire bonding, not only the gold wire, but also the aluminum wire. So we will do the application test for every batch in-house, in Focuslight's house. We also do the die bonding and do the die sharing test to confirm the coating is reliable for the laser chip bonding. So what is our application test for the device? Yes, we use our standard substrate and the laser chip, two kinds of laser chip. The first one is 22 watt. The second one is the 30 watt. You can see the cavity length is the same, and the emitting wise is different, little different, and the emitting area is different. And we use same kind of substrate to bonding different laser chip. The power is high to 25 watt or 30 watt. You can see we got a different result for different temperature, 25 degree, 35 degree, and 45 degree. You can see the profile is consistency. So which prove the substrate is stable, even in higher current. In higher current, the higher temperature. And we test the device, the 30 watt chip with the 30 watt chip, test the device, increase the current from 0 to 48 amps with CW mode. And we got more than 39 watt limit power, which shows a very high reliability for the substrate. And we test lifetime under different conditions. For the first laser chip, we test the lifetime under 22 amps and 25 degree, and we got more than 800 hours, which shows very high reliability for the substrate, even for the device. And for the second lifetime, we test the lifetime under 30 amps and high current 35 degree. We got more than 1,200 hours, even more than 1,300 hours, which shows higher reliability and the higher stability of coating. You can see the power profile is consistency. So now we have 3 standard products for our coating pre-deposited DPZ ceramic substrate. You can see the difference are the size, but the thickness is the same. Just the length and width is different for different size of laser chip. Under the coating pre-deposited copper tungsten substrate, we also have 3 standard products. You can see the length, width, thickness is different, but the thickness of coating is same because we use same process for coating. And we also have some metallization service for our customer. We can do titanium, platinum, oro service, metallization service, even nickel and plating service, even coating, solder, metallization service. And if you have some requirement for this, we can do this for you. We can do this for you. Even we can use our experience in application. We can help you to use this better for higher performance in your device. Now we have more than 500,000 pieces monthly capacity, and we are continue to expand more. So just a conclusion. Coating thin film produced by some thin film technology. For example, PVD process is a critical technology to enable the device, the quality, the reliability, and the stability to be higher. Compared with the indium solder and other solder, the coating is a best solution for laser chip bonding application. And the minimization of thermal resistance and the thermal stress are the key to design design and development the pre-deposited coating materials. You can design the the minimization of thermal resistance and the substrates by changing the different thickness of the layers, even change some materials. And the Focuslight become a vendor for gold team pre-deposited substrate with a rich experience and the know-how of application and a complete quality control system for mass production. We can help customer not only with our substrate, but also with our experience in application. Okay. Just the introduction for Focuslight. Focuslight founded in 2007 by Dr. Liu and headquartered in Xi'an. Now we mainly have three business for the high power laser diode components and materials, which means the photo generation, and the laser optics, which means photo control, and the photonic application module and system, which means photonics application solution. Yes. Okay, that's all for my presentation. If you have any question or any requirement, please contact me. Thank you.
Thank you. Thank you so much for your presentation, Alan. Okay, and so we will move on to the Q&A section. I have a few questions raised by our audience, and I will just ask them right now. Okay, and you may answer them as whatever you want to share with our audience. Okay. Okay. So the first one will be how to choose the solder materials for your sub-mount bonding heatsink. What do you think?
Okay. We also call this sub-mount bonding, call this a second step bonding, because the first step means a laser chip bonding on a sub-mount. Then we bond a sub-mount on a heatsink. So firstly, we need to consider the melting point is lower than gold tin. So in this condition, we advise you can choose the solder with a higher semiconductivity and then lower melting point than a gold tin. For example, the silver copper solder or silver tin copper solder is a best solution.
Okay, sure. And the next question will be you mentioned the thickness of the gold tin is around 6 micrometers. I don't know if I was correct. Okay, so why don't you use the gold tin materials?
Yes. Our standard thickness of gold tin is 6 micron, minus plus 1 micron. I know the cost of material. Cost of thickness of material has some relationship for the thickness of cost. If we use a thinner thickness, yes, of course we will get lower cost. But we need to consider another situation, which means the bonding interface, because usually for our customer application, the bonding interface is not absolutely a quick plat step, because there are some voids and the roughness is not so good. So we need the thicker thickness of gold tin to fill the voids, to transfer the heat, to reduce the risk of bonding interface. So we just use a thicker gold tin, like 6 micron. Yeah.
Okay, sure, I understand. And the third question. Okay, so do you have the business for the metallization service, and what is your design plan? Do you have any thought? Yeah.
Yes. We actually have some metallization service for our customers, like titanium, platinum, and even gold plating, even gold tin solder plating for our customers. Our customer can send us the base plate. We can do the metallization service to them. And the design rule is we need the material with a size about 114.3 millimeters square, and which means can be fit for our diggers, fit for our equipment, and with a lower cost.
Okay. Okay. Sure. And then we have the fourth question will be what is your capacity plan for the Cyronic submount?
Yes, we don't have. We do have because of currently the capacity is more than 0.5 million pieces for every month, and we continue to increase the capacity. We hope in the end of this year we have more than 2 million pieces for from every month for the capacity, because the market is very huge. We will build more and more capacity for this.
Okay, got it. And the next question I believe is raised by a customer who may have interest in your product. So what is your lead time actually? Do you have any thought?
Lead time for standard products, because we build the safety stock for the quick response to the market. So for standard product, maybe 1 or 2 weeks, you can get samples, you can get some batch product. And for customized product, maybe if without the copper process, maybe 2 or 3 weeks to our current customer. The delivery time will be 2 or 3 weeks. And for with copper process like DPC with gold pre-deposited substrate, maybe 1 or 2 months. Yes. Actually, we will make some actions to reduce the lead time in the end of this year.
Okay, got it. Okay, and yeah, we have 2 more questions raised by another audience. Okay, so the first one will be: do you have any technology available to create through vias connecting the top and the bottom surface of a laser diode submount?
Actually, in Focuslight, currently we don't have this process for through vias technology, but we can do this with our supplier. Yes, and maybe for the time maybe in next year maybe we have this technology.
Okay, got it. And the next one would be the application of the coating film in advanced packaging. I would say the customer is trying to, what is the application? Do you have any thoughts?
Yes. I think coating solder is kind of standard solder for laser chip bonding, and I would say for other chip bonding like ultraviolet laser chip, ultraviolet chip, and LED lighting chip, some other kind of chip bonding, because chip bonding is very sensitive to the solder interface. Even for some detective device bonding, they need the solder will be reliable and stable. So I just suggest the coating can be used for them.
Okay. And from the backstage, where I can see that another audience is raised one more question. I don't know if you can answer that. Maybe Ellen, you can take your time. Okay. So the question is how to avoid the coating change color in the process.
Avoid the color change. Avoid the color change. Because the coating is very easy for the oxidation. So we need to keep the coating in some nitride nitride box environment is very sensitive. So we will we need to stop the coating for some oxidation in environment.
Yeah. Sure, no problem. So actually, we need to protect the process in sort of a special environment, like a box or something filled with the nitro gas, maybe like
Yeah.
that, right? Yeah, okay, got it. Sure. So actually, that's all for our questions raised by our audience. So thank you very much for sharing, Alan. And for our audience, I would like to say that thank you so much for participating today's webinar, and I hope you have all the information you need. And another piece of reminder is that the 24th the China International Optoelectronic Exhibition will be held on September 7th to 9th at the Shenzhen World Exhibition and Convention Center. Then you can easily register for the CIOE 2022 by scanning the QR code and fill out the information. I hope we can see you all to our extraordinary event this year, and take care. And till next time. Goodbye.
Thank you. Goodbye.
Thank you. Goodbye.